Hello friends, welcome back to my channel Learning Physics with Bhavya ma'am. Today we are going to discuss significant figures. That is lecture number 6. Significant figures are the number of digits required to express the given physical quantity more accurately. So which tells about how many digits are required to express the given physical quantity more accurately. Significant figure which contains certainly known digits and uncertain digits. So with significant figures is a mixture of, or it is together certainly known digits. That means we are sure about that digit, and one digit we are not sure about that digits. Okay, so significant figures which is a mixture of certainly known digits as well as uncertain digits. For example, time period of simple pendulum is 1.62 second. Here, how many significant figure? There are 3 significant figure, 1, 6 and 2. Out of which 1 and 6 are certain for us. We are sure about these 2 digits, while the digit 2 is uncertain. So that means we are not sure. We don't know whether it is 6.2 or whether 6.3 or it may be 6.1 second. So I am not sure about 2. Okay, this 2 I am not sure about it. But 1.6 is I am very much certain about that digits. So the time period has 3 significant figure. So 1.1 and 6 are certain digits. I am very much sure about that digit. 2 is uncertain for me. So together called as significant figures. Is this clear? So how many significant figures are there? Here there are 3 significant figure. So we know that after measuring, so we are expressing in digits, right? So the digit may be positive digit, so it may be non-decimal or it may be decimal digits. So therefore, let us calculate significant figures. So what are the rules for calculating significant figures? There are certain rules to find out significant figures. The first one is all non-zero digits are significant. All non-zero digits are significant. So if non-zero, there should not be any zero digits. All non-zero digits are significant. So here you can see some examples. 12 is how many digits are there? 1, 2. So therefore number of significant figure 2. So similarly 1, 2, 3, 123, 3. 1, 2, 3, 4, 1234 is having 4 significant figure. Similarly 1, 2, 3, 4, 5 have 5. So 1, 2, 3, 4, 5, 0. So here 0 is 0 digit, right? So you have to count only non-zero digits. All non-zero digits are significant. So you just count number of non-zero digits. So that is 5. The next rule is trapped zeros. That is zeros lies between two non-zero digits are significant. So if 0 is trapped in between two non-zero digits, then it is significant. See for example here 1 and 2 are non-zero digits. 0 is trapped. So you have to count that. So then how many significant figure? 3 significant figure. So let us consider the next example. There are two zeros which is trapped between two non-zero digits. 1 and 2 are non-zero digits. So there are two zeros. Then how many significant figures? So it is 4. Now let us consider. So 1, 0, 0, 2, 0. So here you have to count number of trapped zeros. How many zeros are trapped? Two zeros are trapped in between two non-zero digits. 1 and 2. In between 1 and 2 there are 2. So therefore 1, 0, 0, 2. You just count these 4. Okay, so 4 significant figures. So this 0 is not trapped. It is not between two non-zero digits. That's why we are not considering this 0. Next rule is initial zeros or leading zeros are never significant. So initial zeros. So therefore if there are initial zeros, they are never significant. So how many digits are there? Only one digit. So initial zeros you are not counting. So here how many digits are there? Only two digits. so two significant figures. So initial zeros are never significant. So here trapped zeros you have to count, but initial zeros you are not counting. So therefore three significant figure. So here initial 0.321, this 0 is not countable, so that's why three significant figure. So here the first four zeros you are not counting, so therefore 3405. This trapped zero should be counted. Therefore how many significant figures? 4. The next rule is ending zeros or trailing zeros are significant if they appear after decimal. If they appear after decimal. So that means if only for decimal numbers you have to count this trailing zeros. Okay. If the number is not decimal, for non-decimal number you are not counting this ending zeros or trailing zeros. Let us consider the example. 1.00. So that means this is a decimal number. In decimal number, you have to count this. It is significant. These two zeros are significant. Therefore, how many significant figures? Three significant figures. So let us consider next example, that is 500. 500 is non-decimal number. So therefore, how many significant figures? It is just one significant figure. The next example is decimal 0.150. So you have to count this ending zeros. So first zero should not be counted. Ending zero is counted. Therefore, three significant figures. Then 25.00, it is a decimal number. So in decimal number, these ending zeros are significant. Then how many significant figures? Yes, 4. So here, this is non-decimal number. 10,000 is a non-decimal. Therefore, how many significant figures? So it is one significant figure. Let us move to next example rule. Order of magnitude is never significant. Order of magnitude. So that means 10 to the power. If you write any 10 power plus or minus, whatever it may be. So 10 power is never significant. Order of magnitude means this power is not significant. So therefore, you just count the number of digits. So this is a decimal number. 263. All these three are significant figures. So therefore, three significant figure. Next example, 1.005 into 10 to the power 7. So this 10 power 7 you are not counting. You just count these digits. So how many significant figure? 4. So 3.500 into 10 power 2. So how many digits? There are 4 digits. 4 significant figure. So 1.90 again. It is 3 significant figure. Next rule. Pure number or constant have infinite significant figures. So any pure number or any constant. So in physics there are so many constant terms. All those are having infinite significant figures. Constant, we know that it is a one number, right? So it has infinite significant figures. Examples, as I mentioned, any pure number, any number you can consider. So that pure number is having infinite significant figures. Okay. Or you can consider a constant number like speed of light. Speed of light, all of you know. The speed of light is having how many significant figures? See, if you look at this number, it is 3 into 10 to the power 8. So you might have think this only there are 3, one digit is there. So no, it is infinite significant figure. Okay, it is actually 2.99 something, right? So we have rounded up and we got this number 3, but this constant number is having infinite significant figures. So infinite significant figures. So we know that significant figure is a number of what digits required to express the given physical quantity more accurately, and which contains certainly known digits and uncertain digits. So certainly known digits is infinite. So pure number as well as constant number is having infinite significant figure. Is this clear? Any constant number you can consider, gravitational constant, or it may be electrostatic constant or spring constant. So many constants are there. Planck's constant, are there. So many constant we come across in physics. So all these constants are having infinite significant figures. The next rule: the number of significant figures does not depend on the system of units. System of unit may be anything, so number of significant figure remains same. It may be CGS unit, or it may be SI unit, or it may be FPS unit or MKS unit. So number of significant figure remains same. Example: 16.4 centimeter. So if you express length of the rod in centimeter, then 16.4. So that means if this is decimal number, so how many digits are there? 1, 2, 3 significant figures. So since there are three numbers, so three significant figure. If you convert this centimeter to meter, then we need know that centimeter should be converted into meter by multiplying 10 to the power minus 2. So even if you convert to meter, the number of significant figure remains same, right? So 0.164 here, this is a decimal number, 164 are significant figures. So 3 significant figure. Even if you convert this meter into kilometer by multiplying 10 to the power minus 3, the significant figure remains same. So these zeros, initial zeros are not significant. So next rule is the rule for rounding of a measurement. So if I round up to three significant figure, so then there are certain rules we need to remember. So let us round up to three significant figures. Suppose if the digit to be dropped is smaller than 5, then preceding digit is left unchanged. This is a first rule. So what is that? You need to drop one number. So because we need to round up to three significant figure. So that means the fourth number is dropped. We need to remove that. So that number is smaller than 5, then the preceding digit means the previous digit is left unchanged. You have to keep that as it is. Let us see the example. So here 1.832. So how many significant figures? Here there are four significant figures, right? 1832. Four significant figures are there. But let's round up to three significant figure. We need only three significant figure, that is 1, 8 and 3. Then the fourth digit, this 2 has to be dropped. So this fourth digit should be dropped. If the drop digit is smaller than 5, then preceding digit is left unchanged. So this 2 is smaller than 5, right? So therefore, this digit is smaller than 5. Therefore, we need to write as it is. Okay, preceding digit is left unchanged. Preceding digit is 3, which is remains as it is. Then what is answer? 1.83. Now let us move to the next rule. If the digit to be dropped is greater than 5, then preceding digit to be increased by 1. For example, 1.836. So here we need to round up to three significant figure, that is 183. We don't need this 6. This digit 6 to be dropped. This digit to be dropped which is greater than 5. Which digit? 6 has to be dropped which is greater than 5. Then the preceding digit, we need to add 1 to the preceding digit. Preceding digit is 3, that is increased by 1. So add 1 and what is answer? 1.84. The next one is, if the digit to be dropped is 5, then preceding digit is left unchanged if it is even. So now the digit which dropped is 5. Okay. In first rule we observed that if the drop digit is less than 5, then it keep as it is. If the drop digit is more than 5, then we need to add 1. If the drop digit is 5 itself, then there are 2 points you have to remember. One is the preceding digit is left unchanged if it is even. For example, look at here. So this digit has to be, which one is dropped here? 5. So because we need 184 is a 3 significant figure. The fourth digit 5 is not required for us. We need to drop that. We need to remove this. Okay. Here when we remove that, so when it is 5, then preceding digit, look at the preceding digit, which is 4. If it is even, then the number remains as it is. Left unchanged means it remains as it is. So therefore, what is the answer? 1.84 is the answer. If the digit to be dropped is 5, then preceding digit is increased by 1 if it is odd. If the given number is odd, see preceding digit means before 5. Before 5, what is the number? Before 5, 3. 3 is a odd number. If 3 is odd, preceding digit is odd. Preceding digit is odd. Here it is 3. If the preceding digit is odd, then we need to add 1 to that. 3 plus 1 is 4. Therefore, answer is 1.84. Is it clear? So, these are the 4 rules. 4 rules you have to follow while rounding up the digit. Is this clear, student? While rounding up the digit, there are 4 rules. The digit to be dropped means here it is the fourth digit because we need to round up to 3. So it will be mentioned. Okay, in the new problem itself it is mentioned. So round up to 3 significant figure or round up to 2 significant figure. Then if you round up to 3 here, 1, 2, 3, 1, 8, 3 are 3 significant figures. So we don't need 5. Right. So the fourth digit, if it is less than 5, then it remains as it is. The remaining number remains as it is. Okay. If the number is greater than 5, then add 1 to the preceding digit. So which is a preceding digit? Previous digit. If the number itself is the dropped number is 5, then you have to observe the previous digit. If the previous digit is odd, then add 1 to this number. If it is even, keep as it is. Is it clear? So these are the rules to find out significant figures and rounding of the number. Thanks for watching. And if you like my videos, please like, share and subscribe my channel. Thanks for watching.